Hi folks, welcome back to 6.4 Multiple Angle Formulas, Part 2. So let's take a look at verifying some identities with our double angle formulas. Okay, so in taking a look at this, sometimes it's actually easier to pick the side that looks simpler and make it look more complicated. I know that seems like it's in contrast to what I said earlier, and it's more just the different kinds of problems have different strategies, and we have to be okay being flexible with those. So over here, we're going to take our cosine for theta, and we're going to rewrite it as cosine of 2 times 2 theta. And then we'll keep it equal to the other side. Okay, now what I'm going to do here is I'm going to use the cosine double angle formula to rewrite this side. That will give me 2 cosine squared of 2 theta minus 1 equals the other side. Now, I chose the cosine squared version because I knew that the other side had cosine squared and cosine to the 4th. So I don't want to pick a version that has sine squared. That won't get me closer to what I'm looking for. Okay? Now, if you look carefully, maybe it'd be helpful if we wrote this as 2 cosine 2 theta squared minus 1. And the reason why I'm writing it that way is because I can actually do a double angle substitution again. So I had the double angle here, and I have another double angle here. So I can use the same property one more time. So I'm going to keep the 2 on the outside. Instead of cosine 2 theta, I'm going to write 2 cosine squared theta minus 1, and then minus 1. A lot of writing in this one. Okay, now before we distribute, I forgot that squared. Before we distribute this 2, we actually need to square the thing that's on the inside here. So when I expand that, I'm going to get 4 cosine to the 4th theta minus 4 cosine squared theta minus plus 1. And then the minus 1 on the outside. Okay, now I'm ready to distribute that 2 to all 3 terms, and I'm starting to get some of those 8s that I'm hoping for. So 8 cosine to the 4th theta minus 8 cosine squared theta. Now, just because I'm running out of room here, I'm going to shortcut this a little bit. 2 times 1 will give me 2, and then minus 1, 2 minus 1 will give me plus 1, and that will give me what I have on the other side. All right, so there we have it, folks. A way to use even one more identity that we've learned to verify an identity. Now, we're going to try example 4, and this one is a little juicier, but what I'm really hoping we take away from this is, what do we have happen when we have tangent of 3 theta or sine of 3 theta? What if it's not an even number? And so let's take a look at what we might do. Instead of writing tangent 3 theta, I'm going to write that side as tangent of 2 theta plus theta equals. Now, for the sake of space in this one, I'm just going to take this and just say that it's going to be the same thing every time, okay? Okay, now what can we do? We can use our sum formula for u and v and tangent to take a first step. So I've got tangent 2 theta plus tangent theta all over 1 minus tangent 2 theta tangent theta equals that thing inside the box. Now, I'm going to go ahead and take my tangent to theta, okay, my tangent to theta, and now I'm going to use the double angle identity. And that's going to get me 2 tangent theta over 1 minus tangent squared theta plus tangent theta over 1. I'm going to put it over 1 to set myself up for that next step, okay? Over, I'm going to write this first one as a 1 over 1, same thing, to set myself up for the next step. And with this tangent to theta down here, I'm going to make the same substitution I did on the top. 2 tangent theta over 1 minus tangent squared theta times tangent theta over 1. And this is going to equal that thing in the box. Okay, now we're going to make a common denominator for the top. And I could do times 1 minus tangent squared theta, 1 minus tangent squared theta to that second term. And it looks like I could do the same thing over here, 1 minus tangent squared over 1 minus tangent squared. Okay, let's see where that takes us. My numerator is now going to be 2 tangent theta plus tangent theta times 1 minus tangent squared theta all over 1 minus tangent squared theta. That's the top. The bottom is going to be 1 minus tangent squared theta minus 2 tangent squared theta all over 1 minus tangent squared theta equals the thing I wanted to equal. Now, what we can do here is the 1 minus tangent squared and this 1 minus tangent squared can cancel. And we'll end up with 2 tangent theta plus tangent theta minus tangent cubed theta. So I went ahead and distributed that tangent all over 1 minus 3 tangent squared theta equals the thing that I want it to equal. Now I'm getting pretty close. What I'm going to do here is I'm going to take these two terms, I'm going to make it 3 tangent theta. But then because every single term has a tangent, I can factor out that tangent. And I'm left with 3 minus tangent squared theta over 1 minus 3 tangent squared theta, which equals my right-hand side, which means I have verified this identity. Okay. Let's take a look at this equation and see yet another way that we can use our double angle identities to help us solve other problems. Okay, so I notice that this one has a sine 2x. And so what I want to do is I'm going to take that sine 2x and I'm going to rewrite it using my double angle identity. So sine 2x becomes 2 sine x cosine x plus the sine x that was already there. And when I look at this problem, I realize that I've got a sine x here as well as a sine x here. So I can factor out a sine x. That leaves me with 2 cosine x plus 1 equals 0. Now when we're solving these equations, it's actually really good when it equals 0. Because now I can say that sine x equals 0 and 2 cosine x plus 1 equals 0. Now this one is pretty straightforward. I think about my unit circle and I know that the y values are 0 when x equals 0 and when x equals pi. Now I don't need to do the plus pi plus n pi or anything like that, because I only want to find the solutions between 0 and 2 pi. Now, the second part of the equation, I have to do a little bit of work. So I'm going to subtract this 1, and then I'm going to divide by this 2. That gets me cosine x equals -1/2. Now, if I think to my unit circle, where are the x values equal to -1/2? I'm going to get 2 pi over 3 and 4 pi over 3. And this equation has 4 different solutions. Okay, we're going to stop this video here. In part 3, we're going to talk about half-angle identities, or also known as power-reducing identities. See you there.